Hi, I'm Keith Foles, creator of Neatoo. In this video, I'm going to show you how Neatoo is a full-featured domain-driven design framework for .NET. I've been a .NET developer for over 20 years and an enterprise architect for over 10 years. I've seen firsthand the difficulty of having different platforms for the application's UI and server backend. A lot of business behavior ends up being duplicated. That's why I'm so excited for WebAssembly and Blazor. Now we can use our same .NET library on the client as the server. Thus, we can have the same entity classes on the client as the server. The business behavior no longer needs to be duplicated. All that's needed is to transfer the data. Transfer data? Easy. .NET can already serialize and deserialize our classes. It can even use Roslyn source generators to define the serialization as compiled code. The value of having the same entity classes with their encapsulated business behavior on the client as the server cannot be understated. This is the essence of Neatoo. With Neatoo, there's no need to create individual endpoints or DTOs to describe behavior or transfer data. As stated, all of the behavior remains in the entities, and Neatoo handles all of the general behavior like transferring the data and data binding. With Neatoo, developers can finally focus on what really matters, defining the business behavior. Neatoo features business rules, where you put your business logic and your validation. It features authorization, 3-tier factories, metastate properties, data binding, dependency injection, async await, everything you need to write a domain-driven design aggregate in Blazor with less code than ever before. Don't believe me? Let me show you. So this is the example application in the Neatoo GitHub repository. You can see it's just a simple person entry form. It is a standalone Blazor WebAssembly application using .NET 8. So we're going to quickly look at the features in the example application, including the simple CRUD operations, the business rules, and the authorization before we take a look at the code. So let's first see the CRUD operations in action just to get those out of the way. So add some data here, add a phone number, update, fetch, there it is, add another phone number, update, so that worked. We'll change some of the information, update, make sure that worked, so that all worked. Maybe we'll delete a child, so that worked, and then delete the entire object graph. Nothing to fetch, we're back to create. So we see the standard CRUD operations in action. So let's see our business rules in action. First, a simple business rule, just that a field is required. So if I don't fill in last name, I get an error. Last name is required. So that's pretty straightforward. Now let's look at some more complex business rules that I've included to highlight Neatoo's capabilities. And the first one is that the first and last name of the person must be unique. There can't be another person with that same first and last name. And that in the list of phone numbers, there can only be one phone number for each phone number type, and the phone numbers themselves cannot be duplicated in the list. So what's interesting about the name is unique rule is that this requires a trip to the database and back to ensure what's been entered is unique against the existing records. So to highlight this asynchronous nature, if I put in delay, we'll actually see a 5-second delay added to this call, so we can see that these two text boxes will be grayed out and the update button will be grayed out while it's making this call. So here we're illustrating both the asynchronous nature of the business rule and that Neatoo gives bindable is busy metastate properties so that the UI can give the correct user experience while this asynchronous business rule is executing. And then of course, if it does find a duplicate, as I can illustrate by just putting fail, we'll get errors that these values aren't allowed in the first name last name field. So we see our unique name rule. Now let's take a look at the rules around the list of phone numbers. So if I add a phone number, but now if I add a second phone number, it's all about duplicates. The first error is that I can't have duplicate phone types. And so if I fix that, and I can fix that by going back to the first one, then we get down to our required field. Then I also get that the phone number must be unique, and it flags both phone numbers. But again, I can go back to the first one and actually change that, and the data will be correct, and it'll allow me to update. So there we see rules around a list, which is another level of complexity. Now let's look at authorization. So this entire time I've had full authorization rights, but I just have simple roles here at the top allowing me to do the CRUD operations, and they just build on each other. If you have fetch, you have create. If you have update, you have fetch. And the first thing we'll notice is that user feedback that's given. So if I don't have the rights to fetch, the fetch button is grayed out. So beyond giving good user feedback is actually protecting the API call. So you can see I don't actually enable or disable the update button. So if I'm allowed to try to update even when I don't have rights, I just have the fetch role, I don't have the update role, I'll actually get an exception. And so it's hard to see here, but we actually get a not authorized exception at our application service. So we see that we get user feedback and we get protection at the application service level based on the authorization that's been granted. So there we see the features of our example application. It has the CRUD operations, business rules, and authorization. Now let's take a look at the code. And you'll see that there's not a lot of user code. The entities are very focused on the business behavior. It's Neatoo that adds what is needed for this more general behavior. So let's see this. So as we look at the code, on the left is going to be the user code, the code that you write, for instance, for your entities. But on the right, this is all code generated by Neatoo using Roslyn source generators custom to your entity. And we're going to see a repeating pattern, and that the generated code is based on attributes that decorate our class and its methods. So on the left, we see our person entity, and this is an aggregate entity, and it happens to be our aggregate root in this case. It does have a class that it inherits from. It actually inherits from Neatoo entity base, which is what provides the business rules, the data bindable properties, and all our meta properties like is valid and is busy. So next we see our constructor. We see that it does support dependency injection. This is part of the framework. We just passed this through. But our unique name rule, this is user code. So we add in the constructor our business rules, and our business rule is actually a separate class. So we have some decoupling, and we can test the business rule on its own. So we add our rules in the constructor. We'll go take a look at the code for the business rule shortly. Next we see our properties. So we see our attributes that gave us our label and our error message with our simplest business rule, the required attributes. But we'll notice that all these properties are partial. So this is the first instance where we have Roslyn source generation. So if we look on our right, we see that since the properties are partial, starting in .NET 8, we could actually define the properties in a partial class. So Neatoo is using Roslyn source generator to define the getter and setter because these are methods to support the execution of the business rules. So we see Some Roslyn source generated code there. Going down, we'll notice these partial methods. And again, this is Neatoo taking advantage of Roslyn source generation to actually create mapping methods. So this is a completely optional thing, but you can define a partial method and with whatever type, and Neatoo will match up based on property name all the properties. So as we continue, we see our data mapper methods, create, fetch, insert, and then there's update and delete. And these are what lead to the creation of the factory by Neatoo. So if I pull up on the right here, iPerson factory and its implementation is generated by Neatoo based on these methods and these attributes decorating the method. So if I delete the fetch attribute, the fetch method will disappear. If I add it back, it comes back. So even beyond that, this is live generated code. So if I change the signature of my method, this iPerson factory being generated is specific to my entity, so then it adds that integer. And since our UI is using this method to fetch the person entity, I'm actually getting an error now. You can't see the error, but it's missing the ID. So this is where there's really a generational leap with Roslyn source generators. With frameworks I've worked with in the past, they've been forced to use reflection, so you wouldn't know about an error like this until runtime. Where now, with live source generation, the signature changes in the generated code. You get visibility because you can see what Neatoo is deciding to do, and you get the connection to other code, and you get compile time errors instead of runtime errors. So this leads to better usability for the developer, better visibility to the developer, and it also leads to much better performance because now instead of using reflection to make decisions at runtime, these decisions are being made at compile time. So really one of the key new features of Neatoo that it brings for domain-driven design. Let's go back and take a close look at our fetch. This is a data mapper method, but in the Neatoo namespace, this is a factory operation. We can see that we can inject services. So we inject them here in the method because we only want these on the server side in the application service. And then we do our data mapping, and we can return, in this case, true, or if we return false, this lets us know that the record couldn't be found. But all of that type of logic in these methods is very arbitrary. Neatoo is what gets us from the client to here and gets us our dependencies. That's what this remote attribute is actually signifying, that we are on the aggregate root and that we want Neatoo, if this factory operation is called on the client, to serialize the entire aggregate object graph, serialize it from the client to the server, deserialize it there, and call this fetch method on the server providing these services. And then when the operation is done, when we get to the end of this fetch method, it then serializes the object graph and returns it to the client. So that's a brief discussion of our factory operations, our data mapper methods. But what about these authorized methods? How does authorization work in the factory? So let's take a look at that interface and its implementation. So here's the interface and the implementation. So we support dependency injection. Here we're just injecting our representation of the user, and then this is all user code and it's all arbitrary. I'm returning true or false based on whether I have that role or a greater role. So you write a simple class like this, but how does it get linked back to our factory? Well, surprise, surprise, it's all based on our attributes that decorate our methods. So iPerson auth, this was our type defined in our authorize attribute on our person entity. This has methods that are then decorated with this specific authorize operation flag. But how do we get from our factory operation methods to authorize operations? Well, the factory operations are actually represented by an enumeration that is in of itself a bitwise OR of the authorize operation. So we see this is the bridge. So for instance, a fetch is a authorize operation dot fetch or a read. So if we go back to our person model auth, we'll see that we would expect before our fetch method is called here in our person model, before this is called, we would expect certainly this to be called, but we'll also call this method because it's a read, bitwise, or a write. So in fact, it's any factory operation. And we see that's what occurs if we go back to our person entity. Again, because this is all Roslyn source generation, I can find everywhere this is called, and outside of my test it's only called in one place. So now we're back in our generated factory, and here I can see that before I call my fetch method here, I call has access and has fetch, and if either of those return false, I return without calling my fetch method. So this is our layer of protection, and it's all defined in our entities and this authorize object supporting our entity, and then Neatoo actually does the work of connecting the two together and generating the code that it takes. It's not making these decisions via reflection at runtime. It's actually connecting your entity and this authorization class at compile time and writing the factory that it takes to do your authorization and to protect your factory operation. So there's a quick overview of authorization. So now we didn't actually look at how the business rules are implemented. So I'm actually going to close the generated code because there isn't generated code involved with our business rules. So again, if we're back in our entity, I can make the code bigger now that it's just this. So we're adding this unique name rule. So if we go look at unique name rule, see the interface here and its implementation. So this is the business rule. So it does inherit from a rule base, in this case async. And then this is important, it's signifying that it operates on an I person. So then now we know that we're working with an I person and what specific properties are available. The next thing is that the concept is that we trigger on property change. So in this case, we'll trigger on first name or last name changing. So every time either of those change, this execute method will be called. So this is the core of our rule. So the way the execute rule works, very briefly, if you return none, then that means that there's no invalid values. But if you return a pair of a property name string and a message, this will signify that this property is invalid. So in this case, we're actually labeling two properties of our iPerson entity as invalid by returning this. So there is an important point here to discuss, and that's with domain-driven design, there's a good principle that you should only edit your aggregate through your aggregate root. And that's to ensure that at all times your entire aggregate object graph is valid. Well, Neatoo goes about it a different way with this rule engine, and that's with the goal of supporting binding. So by doing this, if a single entity is invalid, Neatoo has an invalid metastate on the aggregate root. So the goal is achieved that it's clear if the aggregate root is valid, but that's because if any of the children are invalid, even if their properties changed through data binding, that will be bubbled up and reflected in the aggregate root. So that's another key feature of Neatoo to support domain-driven design with data binding with much less code. Again, it's also making use of the fact that we can data bind straight to our entities in Blazor with our same C# library with our user code thanks to WebAssembly. So we see the picture that's starting to form with all these new technologies. So one more point to cover with this rule is this is actually calling the database or using data from the database. So how are we getting to the application service and back with each call to this rule? Well, that is being done by this unique name .isUnique name. Now this is a delegate that we're injecting and calling. And if we look at the definition of that delegate, we actually see, I guess I said we were done with Roslyn source generators, but we're not. Because another feature of Neatoo factories is being able to do an execute, or what's referred to many times as a command. I can just define a single method that will always be called on the server. So that's what I'm doing here. I have a static class and a static method, and it's calling, or it's defining this isUnique name method. Since we're on the server, we can define and get our DB context, and we can return if these values are unique. So a nice simple command, and then this is all the code that it takes. If we go to the code that's generated, we'll see here it generates the delegate for us, and then it also, without going into the details, if we're on the client, it registers unique name.isUnique name one way, and if we're on the server, it just calls the static method. So another thing that Neatoo brings is that as you add entities, as you add factory methods, the factory operations, as you add these commands, you don't have to add controllers, you don't have to add DTOs, the infrastructure doesn't grow at all. Neatoo is able to generalize all those operations, so you can just focus on the specific business logic and continue to add it. Again, if system.text.json can use source generation for serialization and deserialization, why can't we? And that's exactly what Neatoo does. And since I have the behavior on my client, just to repeat it again, I have it on my client in my same C# library with all my user code. All I need to transfer is the state of my entities and my value objects. So that's the concept that Neatoo is built on, and the efficiency of that really shows with commands. This is all I need to write to be able to asynchronously call the server or make a call all the way down to my database using my DB context. So that's Neatoo. What do you think? To recap, the entity classes with their encapsulated business behavior are used on the client and the server. They are data bindable. Property changes trigger business rules that can transform and validate the entity. There are bindable metastate properties to support the UI. Transferring the data between the client and the server is handled by Neatoo. Live source generation is used to define a factory for each entity that authorizes the factory operation and transfers the entity's data. This gives you readable code that you can fully debug. It also provides some amazing performance. The authorization is highly customizable. Yes, with Neatoo, you can write domain-driven design aggregates with less code than ever before. Do you agree? Let me know in the comments below. And thank you for watching.